Hello friends, this video on relation and function part 7 is brought to you by examfear.com. No more fear from exam. Before watching this video, you should have watched relation and functions part 1 to part 6. The graph of greatest integer function. So what is greatest integer function? Greatest integer function, it takes the greatest value. It is denoted by this box in x. And in this case, domain is R and real range is only the whole number, because if you give 1.2 it will make it 2. If you give 1.7 it will also make it 2. So range is only the whole number. So the definition is, if the number is between -1 and 0, it becomes -1. If the number is between 0 and 1, it becomes 0. If the number is between 1 and 2, it becomes 1. Sorry, in this 1.2 will become 1 and 1.7 will become 1. So let us take this y and this is x. We'll say x is equal to with say 1, output is 1. We'll say 1.2, output is 1. Correct? Because this is the bracket in which it lying. We'll say 5.2. The output will be 5. We'll say 4.2 or 4.3, it will be 4. Let's take some negative values also. We'll say -1.5. So -1.5 is not in this range, so it will become -2. We'll say -0.5, it will become -1. Now let's plot this point. We'll take 0 also. X is equal to 0, y is equal to 0. So 0, 0 is 1 point here. When you say x is equal to 1, y is equal to 1. When you say x is equal to 1.2, y is equal to 1. X is equal to 5.2, y is equal to 5. X is equal to 4.3, y is equal to 4. X is equal to -2, -1.5, this range, y is equal to -2. X is equal to, in this range, 0 and 1, it is -1. So if you see this function, for any value from 0 to 1, the answer is 0. Similarly, for 1 to 2 is 2, 2 to 3, 2, 3 to 4, 3, 4 to 5, 4, 5 to 6, 5. 6 to 7, 6. Similarly, 0 to -1, -1. -1 to -2, -2. -2 to -3, -3. So this is how the signum function looks like. Also, point to be noted that if it is 1, it is not 2. It is 1, it is 1. Note that if it is 1, it is not equal to 0, it is 1. So here we'll put a open interval. Why? Because for 1, this is 1, not 0. Here also we'll put an open interval. Similarly, we'll have to put an open interval everywhere on the tip, because at that point of time it takes the higher value. For example, in this case, for 6, it is not 5. For you say 5.999, it is 5. But the moment it is 6, then this value will be not counted. So in that case, this value will be taken. So on the tip we have to create this open intervals. This is mandatory. If you don't do this, the graph is wrong. Without open interval, this graph is wrong. Please make a note of this. Open interval is very important here, because for example, when you say 4.9999, this will give you 4. But the moment you say 5, this will give you 5. So here in this case 5, you say 4.999, it is this. And when you say 5, it is 5. So 4.999 is given by open interval of this. Now let's discuss algebra of functions. So we can add two real functions. We can subtract two real functions. We can multiply a function by a scalar. We can multiply two real functions. We can divide two real functions where we have to make sure that gx is not 0, because if it's 0, fx by gx, it becomes infinite. Let's take addition. So when you say fx is equal to fx plus gx, let's say fx is equal to 2x plus 3 and gx is equal to x square plus 3x. So when you say fx plus gx, you add these two functions. This becomes 2x plus 3 plus x square plus 3x. It becomes x square plus 5x plus 3. So this is one example of addition of two real functions. Let's take subtraction of the real function fx minus gx. Similarly, we can have fx is equal to x square plus 2x plus 1 and gx is equal to x plus 8. So when you say fx minus gx, you actually subtract these two. So what you get is x square plus 2x minus x plus 1 minus 8. This is nothing but x square minus x minus 7. So this is fx minus gx. Similarly, when you say that you multiply a scalar with a function, so for example, you have fx is equal to x square plus 2x plus 3 and you have a is equal to 5, then you say a into fx or 5 into fx is equal to x square plus 2x plus 3. This is equal to 5x square plus 10x plus 15. When we say that we multiply two functions, then we actually multiply. Fx is equal to, let's say, x plus 1 and fy is equal to 2x plus 3. When we say, sorry, this gx. When you say fx into gx, you mean to say x plus 1 into 2x plus 3, and that is equal to 2x square plus 3x plus 2x plus 3, and this is equal to 2x square plus 5x plus 3. This is the answer. So you can multiply two functions. Similarly, you can divide two functions. For example, you have fx is equal to x cube plus 2x square plus 3x, and you have gx is equal to x. You say fx by gx, this is equal to x cube plus 2x square plus 3x divided by x, and this is equal to x square plus 2x plus 3. Thus we have seen that we can add two functions, we can subtract two functions, we can divide two functions, we can multiply two functions, or we can multiply a scalar to a function. Now we have a set given in form of x comma y. We have to find linear equation. Linear equation is always in the form y is equal to mx plus c. Correct? So now we have been given that x is equal to 1, y is equal to 1. If you give x equal to 2, y is equal to 3. If you give x is equal to 0, y is equal to minus 1, like that. So let's first put x equal to 0. So in this case, this will be 0. So we'll say minus 1 is equal to m into x 0 is equal to 0 plus c. So c is equal to minus 1. That is clear now. So we have equation of form y is equal to mx minus 1. Now let me put x equal to 1. Y, the output is 1. So we'll say 1 is equal to m minus 1. So m is equal to 2. That is also clear. So our equation is actually in the form of y is equal to 2x minus 1. So now we have to find the function. So the function is nothing but fx is equal to 2x minus 1. This is the answer. What we have done, we have taken a general equation fx is equal to mx plus c or y is equal to mx plus c, because that's the linear equation they are talking about. So now and they have given different values, so we have put the values and found the value of m and x, m and c. M comes out to be 2 and c comes out to be minus 1. So we have replaced the value of m and c in this equation. So we got y is equal to 2x minus 1. So fx is equal to 2x minus 1 is the answer. Here we have a question where we want to find the domain of function. So we have, this is of the form fx by gx. Now in this case gx should not be equal to 0, because if it is equal to 0, this will become infinite. So that means x square minus 5x plus 4, the one in the denominator, should not be equal to 0. So should not be equal to 0. So we say x square minus 4x minus x plus 4 should not be equal to 0, or x minus 4 into x minus 1 should not be equal to 0, or x should not be equal to 4 comma 1. So when we say, when we're talking about domain is any real number minus 4 comma 1 set, and this is the answer. You got what we have done? So we have seen that this was of the form fx by gx, and we know that this function to exist, gx should not be equal to 0, and that's what we have done. We have told that x square minus 5x plus 4, that is the denominator, should not be equal to 0. We have solved this and we found that x should not be equal to 4 or 1. So the domain of this function is any real number, is any real number minus 4 comma 1. Let's take one more example where fx is equal to this and gx is equal to this. We have to see whether this is function or not. So for 0 to 3, we'll write the value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For 0 to 3 it is x square. So it is 0 square, 1 square, 2 square, 3 square. For 3 to 10 it is 3x. 3 into 3 is 9, 3 into 4 12, 3 under 15, 16, 18, 21, 8, 3, 24, 9 into 3 27, and 3 into 10 30. So this is the relation. This is x and this is ffx. So we see that for every input there is only one output. For 3 we have only 9, for 4 we have 12, for 5 we have 15. So it is a function. Now let's see the scenario 2. Again let me write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For 0 to 2 it is x square, 0 square, 1 square, 2 square, 3 square, sorry, only 0 to 2 square. Now from 2 to 10 it is 3x. So for 2 also it is 2 into 3, 6. This is 3 into 2. This is 3 into 3, 9. 4 into 3, 12. 15. 5 into 3, 6 into 3, 18. 7 into 3, 21. 8 into 3, 24. 9 into 3, 27. And 3 into 10, 30. So we see for a given input 2, there are 2 output, 4 and 6. So this is not a function, but this is a function. So what we have done, we found all the values of x and y, and we found that in first case for every input there is only one output, but for second case gx, we found it for input 2 there are 2 output. So gx is not a function.
Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors,